Welcome. Today we're going to pull back the curtain on a really powerful statistical tool, one that helps experts make sense of our incredibly complex world. So here's the game plan. We're going to start with a problem that analysts run into all the time. Then we'll introduce the perfect tool for the job. We'll see how it works, learn the absolute must-know rules, and finally, figure out how to check if the answers it gives you are actually trustworthy. Okay, let's dive right in. Our journey begins with a fundamental challenge, just trying to find clear answers in a world that is jam-packed with interconnected variables. I mean, think about a huge question analysts wrestle with every single day. What really makes a stock go up or down? Is it the overall market, the size of the company, something else entirely? And you know, the simple truth is, it's almost never just one thing. As our source material points out, trying to explain something with a single cause, especially in finance, just isn't enough. Most things in life have a bunch of causes all working at the same time. Thinking there's only one cause is kind of like trying to predict a house's price by only looking at its square footage. You'd be missing so much crucial info. You've got to look at its location, its age, its condition. You need the whole picture to get it right. Right, so how in the world do you get a handle on all these different factors at once? You can't just wing it. You need a specialized tool, one that's built for exactly this kind of complex problem. And this is where our hero tool comes in, multiple linear regression. It's basically a method that lets us take one thing we want to understand, that's our dependent variable, and see how a whole bunch of other things, our independent variables, all work together to influence it. All right, so now let's pop the hood and actually see how this powerful thing works. What's the blueprint? Okay, don't let this equation scare you. At its heart, it might look a little intense, but it's actually just a super logical and elegant way of adding up the influence of each different factor to predict an outcome. So let's really break that down. See that Y? That's the thing we're trying to predict, like a stock's return. B0 is our starting point, our baseline. And then you have all the other Bs. Those are the coefficients, and they are so important. They tell us the exact power each X factor has on our outcome. And this flow chart, this shows you what an analyst really does. It's not just a one-and-done calculation. No way. It's a careful process, a cycle of estimating, analyzing, checking your assumptions, and then tweaking the model until you get it right. But here's the thing. Having a powerful tool like this is one thing. Knowing how to use it is another. It's like being handed the keys to a Ferrari. You gotta know the rules of the road, right? Because, and our source material is very clear on this, if you misuse this tool, you can end up with totally misleading results. You might start seeing connections that aren't even there. The pros call them spurious relationships, which is really just a fancy way of saying you're chasing ghosts in the data. So to avoid that, you've got this crucial 5-point checklist. Think of it as the analyst's non-negotiable pre-flight check. Your relationships need to be linear. Your model's mistakes or errors need to have a constant variance, that's a big word, homoscedasticity. Those errors also need to be independent and follow a normal bell curve. And finally, your inputs can't be all tangled up and explaining the same thing. So how do you actually know if you followed all those rules? Well, you don't just guess. You got to put on your detective hat and look for clues in the data's fingerprints. And these are called diagnostic plots. First up, you've got the scatter plot matrix. And honestly, this thing is a lifesaver. It lets you see all at once in one big picture if there are any obvious linear trends between the thing you're predicting and all the factors you're using to predict it. Okay, next, after we build a model, we plot its mistakes. The pros call them residuals. And what you want to see is, well, basically nothing. Just a random, boring, shapeless cloud of dots like this one. No funnels, no curves, no patterns at all. That's a sign of a really healthy model. And for our last check, we have this. The QQ plot. It looks a little fancy, but the rule here is super simple. Are the dots hugging that straight line? If they are, that's another big check mark. It tells you your model's errors are behaving just like they should. So, what's the big takeaway from all this? Multiple linear regression is an absolutely fantastic tool for making sense of a messy world. But, and this is a big but, its magic only works if you do your due diligence and carefully check that all those crucial assumptions hold up. So I'll leave you with this question. Now that you have the blueprint, what's that one complex puzzle in your world that you're ready to start investigating?